Hi all, welcome to i-tutor Academy. In today's session, we will start with the Unit 7 subsection 4 of MMPC 010, that is production function with the two variable input. Now we turn to the case of production where two inputs, that is say capital and labor, are variable. Although we restrict our analysis to two variable input, all of the results called for more than two also. So we are restricting our analysis to two variable input because it simply allow us the scope for graphical analysis when analyzing production with more than one variable input. So we cannot simply use set of AP and MP curve like those discussed in section 7.3. And because these curve were derived holding the use of all other input fixed and letting the use of only one input vary. If we change the level of fixed input, the TP, AP and MP curve would shift, and in the case of two variable input, changing the use of one input would cause a shift in the MP and AP curve of the other input. Hope you remember MP and AP curve. So please refer our last section and last video for MMPC 010, that is 7.1 to 7.3. Okay, for example, an increase in capital would probably result in an increase in the MP of the labor over a wide range of labor use. And production isoquants, in Greek word iso means equal or same, and a production isoquant, that is equal output curve, so is the locus of all those combination of two input which yield a given level of output. With the two variable input capital and labor, the isoquant give the different combination of capital and labor that produces the same level of output. Example also here, please go through it. And here is the figure 7.2, that is production isoquant. This isoquant shows the various combination of capital and labor input that can produce 5 units of output. So this is that labor, here is labor input and this is capital input. And 7.3 is isoquant map. So these isoquant shows the various combinations of capital and labor input that can produce 10, 15 and 20 units of output. So this is 10, this is 15 and this is 20. Okay, so here in this x-axis this is labor input, and in y-axis there is capital input. Okay, so please refer your IGNOU study material parallel this video, so it will help you for more understanding. Okay, so next is marginal rate of technical substitution, and as we have seen above, generally there are number of ways that a particular output can be produced. The rate at which one input can be substituted for another input if output remain constant is called the marginal rate of technical substitution, that is MRTS. So it is defined in case of two input capital and labor as the amount of capital that can be replaced by an extra unit of labor without affecting total output. And so this is an example, and it is a customary define of MRTS as positive number. Okay, so this is, please go through it, so this will help you for your more understanding. And this is the map of marginal rate of technical substitution. Okay, so this is that map, so this is the curve for that. And there is a simple relation between MRTS of labor for capital and the marginal output MPK and MPL of capital and labor respectively. And there are vast difference among input in how readily they can be substituted for one another. Okay, example, in some extreme production process one input can perfectly be substituted for another, whereas in some other extreme production process no substitute is possible. On the other hand, in most of the production process what we see is imperfect substitution of input. Okay, and here is 7.5, there's three general type of shapes. Okay, so this is one, panel 1, panel 2 and panel 3. So this is different type of shape. So this is the one L shape, so this is simply a line shape, and this is the curve shape. Okay, and the economic region of production, isoquants may also have positively sloped segment or bend back upon themselves. So figure 7.6, so here is 7.6, that is economic region of production. Okay, so this is one more shape, so these are the two curves, and this is three more curves like this. Okay, this is economic region of production. And above OA and below OB, the slope of the isocant is positive, which implies that increase in both capital and labor are required to maintain a certain output rate. So, if this is the case, the MP of one or other input must be negative. Above OA, the MP of capital is negative. Thus, output will increase if less capital is used while the amount of labor is held constant. So, below OB, the MP of labor is negative, like this. And next is the optimal combination of input. In the above section, you have learned that any desired level of output can be produced using a number of different combination of inputs. As said earlier in the introduction of the unit 1 of the decision problem that concern a production process manager is which input combination to use. So that is what is the optimal input combination. While all the input combination are technically efficient, the final decision to employ a particular input combination is purely an economic decision and rest on the cost. And thus the production manager can make either of the following two input choices. One is choose the input combination that yield the maximum level of output with a given level of expenditure, and choose the input combination that lead to the lowest cost of the producing a given level of output. Thus the decision is to minimize cost subject to an output constraint or maximize the output subject to a cost constraint. So we will now discuss these two fundamental principles. So before doing this, we will introduce the concept of iso cost. So what is iso cost line? So recall that a universally accepted objective of any firm to maximize profit. If the firm maximizes profit, it will necessarily minimize cost for producing a given level of output or maximize output for a given level of cost. Suppose these are two input, that is capital and the labor, that are variable in the relevant time period. So what combination of KL should be firm choose in order to maximize output for a given level of cost? So if there are two input, that is KL, then given the price of capital PK and the price of labor PL, it is possible to determine the alternative combination of KL that can be purchased for given level of expenditure. Suppose C is total expenditure, then C, that is like this. Okay, so this is the equation. The linear function can be plotted on the graph. So this is the iso cost line. So this is the iso cost line. Okay, this one. And example also here. So please go through it. So it will be more clear. Okay. So you should work out the effect on the isocost curve on the following. One is decrease in the price labor, increase in the price capital, decrease in the price capital, and increase in the fame budget with no change in the price of labor and capital. Next is optimal combination of input, the long run. So when both capital and labor are variable, determining the optimal input rate of capital and labor requires the technical information from the production function, and the ISO can be combined with the market data on input price, the ISO cost function. If we superimpose the relevant ISO cost curve on the FAME's ISOCAN map, so we can readily determine graphically as to which combination of input maximize the output for a given level of expenditure. Okay. So here is one problem of minimizing the cost of a given rate of output. So this is the optimal combination of input. Labor input is the here capital input. So this is that curve. And regardless of the production objective, efficient production requires that the isocant to tangent to the isocost function. If the problem is to maximize output subject to a cost constraint or to minimize cost for a given level of output, the same efficiency condition hold true in both situations. So intuitively, if it is possible to substitute one input for another to keep output constant while reducing total cost, the FAME is not using the least cost combination of input. In such a situation, the FAME should substitute one input for another. Example also here, please go through it. Okay. So you should be satisfied that is the indeed the case. So this is one case study, so please go through it from your IGNOU study material. And activity 3 is here. based on this subsection, so it will more clear. Try to do it. Between any doubts, you can contact us anytime. And next is return to scale. What is return to scale? Another important attribute of production function is how output respond in the long run to change in the scale of the frame. When all input are increased in the same proportion, how does output change? Clearly, these are three possibilities. If output increase by more than an increase in input, then the situation is one of the increasing returns to scale, that is IRS. If output increases by less than the increase in input, then it is the case of decreasing the return to scale, that is DRS. Okay, one is increase, one is decreasing. And lastly, output may increase by exactly the same proportion as input. So example is here. So here is one figure isoquant showing return to scale. Okay, panel A, panel B, this is constant return to scale, this is increasing return to scale, and this is decreasing return to scale. Okay, so please try to understand the differences. And in unit 8, we will examine return to scale from the point of view of cost and also advanced reason for increasing the decreasing return to scale. Okay, for the moment, consider the following example is here, and it will help you for your understanding. Refer your IGNOU study material. Okay, so this is about today's section, and for more MBA series, you just do like, share and subscribe our channel. Thank you so much.
i-tutor Academy presents IGNOU MBA Complete Syllabus Coverage Classes for individual students, semester-wise subject with online flexible timing. For more details, contact on +91 623 827 1885